Guys, are you able to see my screen now?
Yes, I'm able to
Yes,
see.
Dinesh. Yeah.
Everyone are
Okay.
able to see the screen.
So, okay, we just go with right now in Spark. So as per the decision, we right now will take for Spark session.
People who have connected in mobiles, no, just you can just expand the screen which you see, and you can see the complete view.
Okay, so you have learned something in Spark, right? So what is Spark? Tell me the answer. Anyone answer, please answer. No issues.
We have not yet learned for us, Abdur here. For us, Hive and HDFS has been completed. Spark has been started.
Oh, yet to start, I guess. Okay. Okay, so Manish, can you tell me what is Spark? Because you
Yes,
learned
so
something, right?
Spark, yes. So a Spark is a distributed computing engine which can be used as an ETL also, like it can be used for processing high amount of data. And the advantage of using Spark is like it is very fast because it does the in-memory computation. Sorry.
That's correct. It's a in-memory, not a distributed computations. In-memory computation engine. My session always will be in interactive, so you just raise your body. Okay, it's not a distributed, disk processed operations. Anything will not be covered in. Okay, and then
Can be used for ETL purpose.
it's not for a ETL only. We can go with real time as well in Spark. It's close
Yes,
to near
yes,
real time.
yes.
Spark is a processing framework. Okay, this is a processing framework because everything will be a framework only we are using. This Hadoop is a kind of framework that's compatible with this ecosystems. And then, okay, we'll go with some architecture flow, then we'll come with that. Guys, please mute if you're not discussing anything right now, because why I'm saying it will be noisy to the other people. If you have any question, you just unmute and raise and then go back to that mute option again. Because this is completely recording right now. Again, I'm saying. And so, okay. So likewise, Hadoop will be available, I guess, right? One master and rest of this will be in slave. Master called as name node. The rest of that will be acting as a data node, right? Data node 1, data node 2, data node 3, and data node 4, right? This is the flow that we are going to interact with our environment, right? So all will be following with name node interaction. And internally it have the replicas. Correct? This is a normal
Yes.
Hadoop flow that we are using right now. This is the entire Hadoop cluster. So we can achieve our data with Hadoop cluster itself, but it will be completely following with MapReduce concept, right? So this will be interact with Yarn. Yarn going to do all your operations. Just inform you. First, I just clarify you with Hadoop architecture, and then I just compare with the Spark architecture. So here node manager available. Each have own node manager. In each node manager available with container and application master. Yarn have resource manager. So resource manager are going to interact with your node manager and processing your data with respect to your client request. So it's going to be work with each node with respect to your node manager. This is the actual flow we are doing. Correct? Do you have any question in this? Anyone?
In the node manager comes under the data manager, right?
Data node only, that node manager will be available. Each data node have one node manager. Node manager available with container and application master.
Okay. Where is that HDFC here?
SDFS, this is the entire cluster is called SDFS.
Okay.
This is the entire cluster. Whatever the data that will be stored, this data available here. All the information will be stored here only. Your files and whatever the block size, everything will be stored here only. Each will be split into 128 MB of sizes and be stored. But name node only have metadata references where actually this file will be stored. This information only is available in name node. Let's say, for example, I'm raising request from as a client. I need to process the data for 1 GB. So I just request to the name node. Name node identified where the data actually is available right now. It's going to be checked whether it will be that 1 GB of data will be split into the 5 or 8 block sizes. Each will be in 128 MB, right? So it will be split. 1 GB of file will be 8 blocks will be created into 3 replica. Total 24 blocks will be created. Correct?
Yes.
So, but whenever we are going to process the data, it should take only 8 blocks. In case of any failures in the block, that time only it's going to be refer another block. Where the actual replica is available, there is going to be get the data and process our layers. That is the flow of MapReduce concept. I hope you know, right? Any question in this?
No. See, that's what actually this process is equal to that. It's Hadoop Spark is the part of Hadoop architecture.
Yeah, this is the Hadoop architecture, and then I just compare with you in Spark architecture. It look like same, but it will be doing different way. That's what I just clearing you with the Hadoop architecture first. I just mentioned here itself. Once you clear, I just compare with the Spark architecture again.
Okay. So the name node provides the head of the here, and the data node is the bottom, and just simply you can tell it the name node provides the data to the
Let's say, for example, I just come and clearing you 1 minute. Here I am the request. I just insert the data SDFS GFS hyphen put abc dot txt file. Okay, this is my command. As a client, I just executed this file
Okay.
available 1 GB of data. Okay. So
Okay.
name node, first this request will be reached into the name node. Name node can identify what are all the data node is available. With respect of that, it just split into the 8 blocks. 1 GB divided by 128 MB, it will become with 8 blocks.
Okay. Okay.
Okay. So first 2 blocks will be stored here. And 4 blocks will be stored here.
Okay.
Rest 2 only, I guess. 4, 6, okay. 1 block. And then here 1 block. Let's say, for example, I'm saying total 8 block of 1 GB of data. That's stored here. Now, with respective of replica, this 2 block data will be stored again in 2 places. The same 2 block size of data will be stored here and here. That is a replica.
So where in the RM Eon also it will save.
No, yarn will not come to this point.
Okay. In the
Okay.
data node, it would, yeah.
Let's
Under
say,
the
for
name node,
example,
yeah.
I will come to your question. Wait a minute. This is a replica 1 and 2 blocks of replica 2 here. Okay, so these 2 will be in the same. This 2 block replica and replica. Likewise, it internally split and store across your Hadoop cluster. This is your Hadoop cluster. Actual data will be stored. So name node have information. This 2 block will be available in data node 1 and data node 2 and data node 4. This information only is available in name node. Whenever I'm going to get the data from this block, name node going to work with this data node with any one of that, because this is a replica data only will be stored. So first is going to be checked with the data node 1 and data node 2, total 8 blocks. As like this, it's going to be referred. In case data node 1 is going to be failure, at the time that same replica where is available, there is going to be get the data from here. This is the way of operation internally it's doing. Clear? Any question?
Okay. 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 Then. If the any node is failure, then it will get the replica from.
Yeah, exactly. That is the use of replications to secure your
That is
data.
RM is replication.
No. Resource manager. This is HDFS storage layer I'm talking about. RM yarn will be coming to this processing layer. I will come to your question. Okay. This is how
Okay.
the data will be stored and how the data will be retrieved. That's it.
Okay. Okay. Okay.
Now I'm coming to processing layer as a yarn. Let's say, for example, 1 GB of data, I'm just going to be count the data, or I'm going to do some, okay, better we can go with count the data. So at the time, what will be happen? Name node going to check with yarn. Yarn create a one job. Okay.
Okay.
Those
Okay.
jobs is going to be worked with this environment as a map reduce flow.
Okay.
That is called map reduce. So it's going to be aggregating your data and it's going to be work with your data and producing your final output to you. Okay. That will be
Okay.
happened by a resource manager. This is called processing layer. While you're going to store the data and retrieving the data, that's called as a storage layer. Just how the data will be stored. But how you are going to process your data with respect to your business queries. Because you need to do a lot of business queries. You need to slice the data. Everything will be doing with map reduce only. That will be controlled in resource manager as a jobs. I just simply telling you, whenever you're going to SGFS, DFS, -ls or any command, it will not be doing any jobs. It immediately retrieving the data to you. But if you are trying with Hive or Scoop or any other tools, at the time MapReduce will be running. Did you notice that? All of you?
Yes.
Yes.
So at the time, it will not be doing any processing layer while you're using SDFS commands. That is called as a storage layer operation will be following the backend. Okay.
Okay. Okay.
Do you have any question till now? Guys, others?
No. So Spark is a similar one to like Hadoop.
It's a part of processing layer to handle your data. How efficiently? I will compare with Spark right now, but before that, I just want to clear you how Hadoop is working. On top of the layer, how Spark is going to be work. That's you need to compare it. That I am trying to tell you.
Okay. See, either my question is whether the Spark we have to choose or Hadoop we have to choose. Either one of the two we have to choose, right?
Hadoop is a top layer, sir. On top of the Hadoop, only Spark is going to be work.
Okay. Okay. Okay.
Data actually is available Hadoop only, right? On
Yes. Yes. Yes.
Hadoop, data is going to be powered by Spark. So the processing layer, whatever is saying, right, map, that process will be covered by a Spark. I guess
Okay.
network is so poor. So this is Hadoop architecture we have discussed. Now I'm coming to Spark architecture. Just one node manager, sorry, one name node, and the rest of that will be going to perform as a data node. Okay, so simple understanding, this is a name node and data node.
अनम्यूट कर देना
Guys, please mute yourself.
बात करना चाहिए इसमें तो वीडियो बात करना तो वो सुना आता नहीं मैं बोल तो सुना आता नहीं
Okay, so this is a normal way data node and name node is available. But Spark, what will be happen? It's going to be checked with your resource manager as a jobs, because here we are using yarn only for the resource controller as a cluster manager. Okay, so when I raise the request, this request name node can understand where the data actually is available, and those information will be transferred from metadata to name node, and name node going to transfer that information to yarn. Okay, yarn going to create as a jobs. So resource manager as a job is going to be take it out. Okay, till now you are clear, right? Any question this? So this is the base of Hadoop, how the flow is doing. I have no question here. So resource manager can split that as a job and it will be transferred into your Hadoop environment. Now Spark is coming here. If you are going to use as a Spark engine going to be work with the node managers. And it will be follow with master and slave internally. That is called worker and driver program. So any one of this data node will be taking the responsibility of driver program, and rest of that will be working as a worker node.
Rest of them as a worker node.
Worker node. In Spark, it's called as worker node.
Okay. See, the
Why
same ETL, data transformation, ETL and the storage system, the Hadoop as well as the simultaneously Spark.
Yeah.
So in both systems, Spark is much more faster than Hadoop, right?
Much more faster than MapReduce, not for Hadoop. You're not.
Okay. See, either one of them thing we are going, either we need to use Hadoop or Spark.
No. You're maybe a little confused.
Yeah.
Okay. So Spark is only processing layer. X faster. Oh, sorry, 100x, I guess. 100x faster than MapReduce. It's not replace your operations. Hadoop always is available because the Hadoop will be following with distributed, data distributed. Spark help to operate on that distributed data with immediate effect. How it will be doing? Via RAM operation. In Spark, you can see, so in Hadoop, all the operation will be doing with MapReduce as a disk process. Whenever the query will be changed, first job is going to be work here, and that data will be stored in node manager itself into the disk as a cache data. Like this, all the data will be stored and finally it just transform into a resource manager as a final output. This is the way that Hadoop architecture is working. But Spark is going to be work with node manager itself with RAM. That is the main difference. Spark will not be replace your Hadoop environment. Actual data will be stored.
Okay, and only the MapReduce
Yeah.
has been replaced. In Hadoop,
yeah, exactly.
Hadoop MapReduce component has been replaced by Spark.
Yeah, exactly. That will be happening. It's a disk process, but you are doing with in-memory analytics. Okay, that is a major difference. Any question?
Okay.
Any other questions there? Others? It internally has the RAM and it's going to be performant. Guys, if no question, then we can go for next.
Yes, we can go for next.
Manish, do you have any question?
No, Dinesh, we can proceed.
Okay. Okay, so till now we have discussed how Spark is working on top of the layer of Hadoop.
I have a question.
Yeah.
The data node itself, the RAM which you are mentioning, is it referring to the physical RAM which is in the system, or is it something else?
No, it's a physical RAM only, right? What is data node?
data node is itself a system and it has a RAM. And even in the Hadoop, it will have a RAM, and it will not use that RAM or nothing like that.
No, actually, it's a data node is also is kind of machine only. So it have own core, own RAM, own disk space, right?
And
That
even
is an important.
in right?
In a in our single, yeah, I'm not getting clearly. Tell me again.
Even in Hadoop, a data node has its own RAM and it uses the RAM for processing. But what is the basic difference within the RAM
Yeah,
which is being versus Hadoop?
uh, that Hadoop will be following with your data node caches. It will not be use RAM operations more. Whenever the query will come, it's going to be work with your data and it will be stored in cache itself. It's called intermediate layers values.
Okay, okay.
But Spark will be working completely in RAM itself. It will not be release the data until the job is completion from the RAM.
Okay.
Okay.
Okay, thanks.
But in MapReduce, whenever the task will comes, it's going to be run to the RAM and store the cache output in your local disk. So keep on, it will be run all your tasks with your RAM and final output going to store in your caches. And then that is called as an intermediate layer outputs. And finally, it's going to be collect based on the reducer and producing the final output to you. So what will be happen if you are doing with MapReduce? It completely following with the RAM and disk, that read and write operation will be followed. Frequently it will be doing. For each task is going to be moved into the RAM, get the cache output and store in your local. It's like multiple tasks. You have a number of tasks available. Those are all will be going to work with your caches, right? It will not be permanently in the RAM. But Spark, it will be stored completely in RAM itself and perform that final output and transferring that final solution to you only. Okay. So the read and write operation, you can avoid it. That is a major difference. That's what 100x faster than MapReduce.
Okay, thanks.
Okay. Any other question?
Yeah. See, the batch processing is real-time processing, right? Spark is real-time processing.
Real time also can possible. Batch processing and real time both will be processed by Spark.
Oh, okay. No. My question is that OLTP, OLAP, and all we will see in the analytics side, that will data deals with real-time processing, right?
Yeah, OLAP is a historical data. OLTP is a real time. That's an online transaction. It's that is part of real time operations. It's concurrency data, everything.
So OLTP deals with batch processing, that is Hadoop MapReduce.
No. You're confused. OLAP is a data warehousing. OLTP is a database. That is a major difference. Okay, if you have a data, it will be completely modified with respect to of your queries. Then the data modified, I'm saying. It's like updates with your data. If it has happened, that is called OLTP. But your data will not be modified. It's a historical storage data. It will be used for your reference. It will be used for coming uh, recent data. It's a help to match with your recent data for the comparison purpose. That all will come to data warehousing. That's a OLAP. That's the old records. Okay. So Hadoop will be stored with a large data set, they are saying. So which means historical data only you have large because n number of years of data you'll be stored. That data you'll be stored here and do some analysis. OLTP you can go with what is that? Databases itself, Oracle or MS SQL Server or whatever. You can go with that itself, but you can compare with your historical data, how the fluctuation was happened. Let's say, for example, this time Indian economy is going to be down. You just compare with last year, the same time period, it will be little high, right? So that last year
Yes.
data you will be used as for references, but you need the data for the comparison itself. So that is called as OLAP data. That recent last 1 month of data will be stored in database itself. You will be doing n number of changes. That all will come to OLTP operations. Okay.
Okay. Okay. So OLAP.
Mainly Spark will be performing with OLAP operations.
Okay. And Hadoop MapReduce also deals with OLAP.
Yeah, that is a major use. What is the use of if you are following with OLAP? What is the difference between OLTP and OLAP? You're just saying, right?
Online.
As a
Yes. Yes.
business, uh, that is okay. I don't want to get that explanation or differences exactly. Why? What is the purpose we will be storing the data?
Yeah, we want to get the history of the data the last year, how much, then we will go for OLAP. So
Okay, so that's called future references.
yes,
Okay, so future references we can use it, and predictions, data, decision making. So data based decision making, that all will be helped by OLAP only, not OLTP will not support you. Okay, let's say for example, this week is a, okay, this is a March month. Okay, okay, so last year Christmas we can see how much sales was happened. So with respect of that upcoming Christmas, how much sale will happen? That we can analyze and take the predictions based on your historical data. So such kind of operation you can go with OLAP. Okay, and that's a profit maximization concept. Today is I'm spending 10 rupees, I'm getting 11 rupees. But if I suppose I'm going to spend 10 rupees, how the possible way to get for 12 rupees? You're maximizing your profit. That all will be calculated only via historical data. Correct? And comparisons. Recent data, whether this guy is have the capable to get the loan or not. With respect of his historical data, we are going to identify this guy, we can provide the loans or not, like that. Blindly, we cannot take the decisions without historical data. So that is a major difference between OLTP and OLAP. Got it?
got it, got it.
Any question?
So here Spark will deal with both OLAP and
But
Spark and Hadoop produce both are deals with only OLAP.
mainly OLAP, but it is possible for OLTP as well, in case data is not changed. That we have multiple devices, right? And even Spark without Hadoop is working. That is a possible right now. Before it was say ecosystem dependency. Now Spark will work without Hadoop itself. So directly you can refer your databases and other multiple databases you have, right? Multiple sources. Everything you can connect via Spark and do your analysis. That is also possible in Spark. That's the reason Spark is very familiar to compare with other ecosystems.
What is so
Okay.
whatever the data, it's processed in the Spark.
Yeah. They will be creating multiple connectivity right now. Okay, even for the cloud also they are going with that. Only with Spark integration they can achieve it. Okay,
Okay, okay,
but Hadoop will be following with multiple ecosystem operations, like we are discussing about Hive. Hive will be using some optimization, partitioning, bucketing, lot of things we are doing. So that integrity and completely always in availability in Hadoop. So your data will always in secure. You can edit where the data is actually available and make distributions. Everything you can achieve via Hadoop. On top of the Hadoop layer, if you are going to work with Spark, it's high efficiency. Okay.
okay, okay, okay. So Hadoop MapReducer only has been replaced with the Apache Spark.
Yeah, that's it. Replaced of MapReduce.
Okay. So on rest of the Hadoop mechanism and everything architecture is using the Spark. Spark using the on top of the Hadoop only
Yeah,
Spark only the MapReducer. Okay, okay. Okay.
yeah, exactly. That's it. Okay, so this is the way how the data is going to work with your Hadoop environment. So one should be in Spark as a driver program, as a master, Spark master, and rest of this is going to be work as a worker. So one will be taking the responsible to work with other ecosystems, the other data nodes, and collecting the data.
Okay.
So internally, it have own algorithm to analyzing with your data nodes. And final output you will get from data node itself. Okay, like this is going to be work here. So let's say 1 GB of data, multiple tasks will be developed, right? These multiple tasks finally transform that final output will be transformed to that resource manager. Resource manager can combine all the information and final output will be storing to you. This is the way in MapReduce will be happen. In Spark, it have own master and slave architecture. That master will not be running into the name node. It will be running any one of your data node. That's a major difference. Okay, so it have the responsibility to control your data nodes entirely and process your data, and final output will be stored in any one node itself and getting the final aggregate output to resource manager directly. And this entire the process will be happen only in RAM. That's a in memory. So the if you are going with this operation, you will not get any latency. With respect to of operation takes efficiency matter more. Okay,
Okay. Okay.
guys, you got the point? Any question here?
No, Dinesh.
You're clear, right?
Yeah,
So
yes, Dinesh.
many of them will be confused here only. The driver program will not be created in name node. This will always will be create any one of your data node. That is called as driver and worker. Okay, that's the main difference. Today is 27 or 8. Okay, so this is the basic flow, how the data will be going to work with you. In Spark, we will not be touch it still. We just discuss what is Spark right now. So you have the basic idea about what is Spark, I think so. And then we'll be go
So
with internal architecture. Yeah, tell me.
yeah. See, in the Spark, we will only deal with the name node and data node, right?
Spark
We,
will not be deal with the name node and data node. Resource manager and yarn cluster manager only deal with the name node and data node. Once data cluster manager can identify where the Spark, sorry, where the data is available, then resource manager is going to be created as a job. This job will be taking with the Spark engine. That is the engine only. So at the time, it internally Spark engine calculates some analysis and providing some final decision to you. That how is going to be calculate that analysis and where the Spark cluster is going to be start driver program and worker program, that are with respect to of user selection we can go. Because Spark, you will be completely developing code itself. Okay. Spark we can write in Scala, Python, Java, and R program. This 4 language only possible to write the Spark code. So this programming going to perform via your resource manager. Okay, but this will be following in multi-threading. Got it? This is the backend will be happen. Any other question?
So we are going to deal with only name node and data node will do manage with cluster manager and resource manager. Under that, underneath, Spark will deal with the
where the actual data is available. All the information you will get from RAM, right?
Yes. Spark will
And
deal
then
with
once
the RAM.
you confirm, and Yarn can identify where the actual data is available, how we can split it. Those basic architecture, once the Yarn is confirmed, then it's Spark going to be take the decision with respect of your Yarn inputs. That is I'm saying again.
Okay.
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 Any other question? Guys, whatever the question you just raised, we will discuss and then go for next. It doesn't matter how long it will take. Whatever the topic I'm covered, that should be understand to you. That's I'm thinking.
Yes.
Okay.
So Yarn will provide the data, input the data, and it will be processed by
cluster
the
information. Just a minute here I can say. So let's say for example I am the client, I am going to process with your data of 2 GB of data, example 2 GB of abc.txt. That's the file I'm going to process via Hadoop environment. This file already stored here. Okay, so 2 GB of
this
data,
is non-structured data.
Structured data, whatever, that's a CSV file or whatever is a file, 2 GB the file size. So abc.txt, where the data will be stored, data node 1, 2 block will be stored. Okay, so total 2 GB now 16 blocks. So 6 block will be stored, and then data node 3 and data node 4 have the replica data. This information will be stored in name node. Let's say for example I'm saying, okay, so this 2 is a replica. And then data node 2 have 5 blocks, and a replica will be stored in data node 1 and data node 3 have the replica of 5 blocks, and data node 3 have 5 blocks of data. Total 16 is coming, right? So here the replica will be stored in data node 2 and data node 4.
Okay.
Okay, this is the information available from name node. Now Yarn is going to be take this information and resource manager created. So first 6 block and data node 1, 2, 3 is going to be performed. So let's say for example, data node 3 is going to be failure. I cannot retrieve the data from data node 3. So data node 2 and data node 4 something. This is 4. Stored $1 is a 4. Okay, so data node 3 is failure. So Yarn can identify with the resource manager. Data node 3 will not be performed, but the same replica data we will be get from data node 4 or 2. That information will be get. resource manager get ready right now with corresponding this information right now, and then it's going to be start any one of this. So we have option data node 1, 2 and 4 only. 3 is failed. So you just internally calculate with some algorithm, can identify and make it one as a driver program. So this option, you also have this option while you're submitting your job in Spark. You can select which one will be in driver program. If you will not require that information, anyone can also take as a driver program that you can provide it as a configuration bot. While I am coming to this Spark submission, I will tell you how it will be possible. Okay, that's a master client or cluster like the deploy mode is available. With respect to of that, driver program can kickstart. And then rest of that is going to be work with worker nodes. And it's going to be internally work with your data node as well as driver program also will be working, and final output, it will be released from the cache and transformed into your driver program RAM. All this information you'll be get here, and then finally this will be calculated and send back the output to resource manager as a final output.
Okay, okay.
And then resource manager confirmed, yeah, the job succeeded without any failures. Even for a single task is failure, it cannot be complete. So resource manager will know that all the job is completed. So all the task is completed, and then job is also completed. Like that, that information retransformed to your Yarn environment to name node. Name node resend that information to client as an output of your queries. This is the flow will be happen. You got it?
Yeah.
Any question right now?
No, nothing, nothing.
Guys, others, are you clear now?
Yes, Dinesh, I'm clear.
Okay. So till now we have discussed about the basics. What is Spark? Somebody is texted in chat. I'm not sure. It's not part of Hadoop architecture. We can use Hadoop Spark with Hadoop, right? Yeah. Yes, Satish is correct. That's a standalone Spark will be performed. Or we can go with other tools instead of Hadoop also possible. That is I'm saying. Guys, am I audible to you? Somebody has mentioned I'm not audible. Am I audible?
Audible, audible.
Any noisy, I guess.
Yes, audible.
Okay, okay, thank you. Okay, so till now is 1 hour. Just 5 minutes break we will take and we'll sit back, okay? And then we will
Okay.
go internal flow, how the Spark is working.
Okay. Dinesh,
Okay, yeah.
just we have discussed, no? This one, Manish, Hive, HBase, what are these things? Yeah, in this slide.
No. I just want to confirm with you that we have 2 batch, right? So I
Okay.
just mentioned that Manish batch and Abdur batch, like that I just mentioned. So what are all the ecosystem was covered. So that with respect to of that, we will be taking the session today. Because he will be split up 2 batch and me and Dinesh Pandey will be covered right now before. But
Yes, yes.
unfortunately the timing we cannot continue that. So that I just mingle both and I just take it commonly with Spark right now.
Okay, okay.
That's just for the reference, for my reference, I just mentioned.
Okay, okay, okay.
Okay.
Okay, okay.
Okay, guys.
So
Just
one more doubt is, that Yarn just still the data, and once if it is processed also by the Spark, we need to communicate to the Yarn.
Yeah, exactly. Because 2 GB of data, right? This 2 GB, how much resources needed? That information you'll get from yarn itself. So
Oh,
2 GB, you need only 2 GB of RAM size is enough, and split with multiple blocks. So each one have to work with minimum of 400 MB of RAM size is enough. We don't want to occupy the entire the RAM for this operation. So it internally split some operations. That is called as container. Resource manager itself, we have a container and something I mentioned, right? So like that, it will be splitting some cache memory. Those cache memory will be allocated for your operation. It completely lock you to RAM. It's a part of RAM will be allocated to your job because multiple job you submitted, right?
yes, yes.
So it will not be occupied the entire RAM. So Yarn can decide how much RAM I can provide you. That is the use of Yarn. Once confirmed the resource, how much resource is needed, and how much what is that? Where the block is available, all the information once get, then resource manager can take the responsible and split your work.
Okay,
Okay. Okay, client one will be provided with 2 GB of data. Client two will be provided with 10 GB of data. At the time, it can be identified how much resource I need to allocate for this particular job. Okay,
okay,
that is
okay,
the
okay.
work of Yarn.
Yes, yes.
Okay,
Okay,
okay, we will discuss internal architecture after 5 minutes.
okay. Sure, sure, Dinesh.
Just take 5 minutes break and
Okay,
10:25 we will be connect back.
okay, sure.
Guys, I'm audible.
Yes, Dinesh, you are audible.
Thank you. Okay. So now we just going to start with internal architecture, how the Spark is working. So all of you know about DAG, I guess. What is DAG?
Directed acyclic graph.
What is the use of that purpose?
Uh, it is like in order to decide the steps of execution of any program, this DAG is used in Spark.
Okay. Execute the program, okay. But why we need to use it exactly? Can we achieve without DAG? Is it possible?
Yes, it is possible, but what it basically does is it creates the execution path from the bottom to top. In that way, what happens, like we do not end up executing unwanted steps.
Okay, it's close to correct. It helps to identify the efficiency.
What, Dinesh? What it is?
DAG, and shortest way to achieve your your job. Simple understanding. Let's say, for example, and we will be in Chennai. So we have okay, we are in Chennai, Gindi. So we have the route to go to Shoringalur. How many ways available? One we can go with Madhya Kailash. Another one we can
Nicholas
go.
with Velacheri.
Yeah, another one we can go with Valacheri, and another one we can go with Tambaram, and from Tambaram to we can go with Shoringalur, Palavaram
No,
road.
another one. No, another one we can go with the airport road.
Yeah,
That
that is
before
also
airport.
possible. So four routes is available, but which one is it very short? We are going with Madhya Kailash is a very short, I guess so. You can see in your Google Maps, whenever you are going to locate any places with the direction, it will be providing multiple ways to you, but it will be linking one particular way. This is the best way to you, like that. You notice that, right? In your Google Map, that is will be
Yes,
happen
yes,
via your DAG only. So this way, if you are going to trying to get your data, this is a better way to achieve it very faster. Here also you can see we have the data node 1 replica 3, sorry, data node 1 6 block replica with the data node 3 and 4. Let's say, for example, my Spark driver is going to be start from data node 2 itself. At the time that yarn can recognize and producing you, which is the shortest path to you to get the data. Okay, this information you will be analyzed internally with your uh, Spark architecture, internal architectures. That is the help of DAG. Once finalized, yeah, this is the way is correct. This is the way if you are going trying to achieve your data, your time very less to producing the final output to you. That information you will be transformed via Spark. So, okay, that is the use of DAG, and it will be following with your transformation actions. Whenever you will be trying to execute your query, it's going to be identified how first which transformation I need to enable it. Like this, we have that multiple transformations available. Let's say, for example, I'm going to find out some data with web classes, filter some data and getting some final output. This is the way I'm going to execute my query. So immediately what will be happen, it's going to be check with your data, and first which one I need to execute. First I'm going to filter the data, and then I'm going to do some counting or whatever the aggregation. This is the flow, right? Otherwise your data will be clumsy, collapsed. So this uh, priority will be assigned via DAG only to you. Okay, we can see this DAG in our real-time aspect. I will show you how while we are going to execute our job at the time I can show you how we can see in reality. Okay, that is the use of DAG. Any question this? It will be followed
No.
with graph algorithm only.
Okay. So DAG will show how to store the data in an efficient way. That is it.
Not store the data, how to retrieve your data.
Okay.
That is the main use
Mm,
of. Okay, let's say for example here I just mentioned, right? So your data will be available data node 1 6 block. The same
okay.
6 block is available data node 3 and 4. Correct?
Okay. Okay.
So let's say for example Spark driver program going to start from data node 1. Then data node 1 6 block is fine. If suppose I'm going to start my data Spark driver program data node 3, at the time I don't want to look for data node 1 because same replica available in data node 3. I don't want to waste my time for the network transfer. Correct? So 6 block data I can internally get from data node 3 itself.
Okay.
That decision making will be taken by DAG algorithm only.
Yeah, Dinesh.
Yeah.
Yeah, the DAG is used for only what the transformation we have executed and when we submitting a job. That is the use of DAG, right?
Yeah. That is the internally it will be following. Those transformations can be followed with your shortest path of your data.
Okay.
Okay, while you are seeing with Spark 1x, you can see how the data will be fluctuated. Spark 2x, they will be completely developed the DAG with data frames mostly. You
Yeah,
just
yeah,
open
okay.
your explain plan, there you can identify this, how the way is working.
That the URL itself it is going to show, right?
Yeah, that's the explain
The
plan,
DAG.
physical way that layers, everything you will be see in explain plan. There you can see how the flow is happening.
Yeah, yeah, okay.
Okay. Any other question?
Nothing. Nothing. Dinesh.
Shall I go next?
Yes. Please go next.
Okay. Next is lazy evaluation. What is lazy evaluation?
Once the job is triggered, only it is going to execute. Otherwise, it is not going to execute. That is the lazy evaluation.
Figure the job means how you will be located.
Yeah, where the Sparks submit, we can that what is
Actually, I forgot to tell you one thing is we can do Spark in two ways of operations. One is called transformation.
Actions and transform.
and another one is actions. In transformation, two types is available. One is narrow, another one is wide transformation. Okay. So this transformation is nothing but it's just simply transferring your data from one way to another structure. Let's say, for example, you have the data for employee data set. You need to slice your data only for those who are getting more than 10,000 salary or 1 lakh salary. That time your data will be sliced. You will not be doing any aggregation in that part, right? You just slice your data and getting the data. So that is the pipeline, get from old one format to new format. So same structure is available. A sliced data will not be getting any final output. It's just structured data only you'll be getting it, right? So that is that are all will come to transformations. You getting my point?
Yes.
No, Dinesh, you are telling that structured data only they are going to process it, right?
No, whatever unstructured data also you just transform from one layer to another layer. Let's say, for example, you have a log file is available. So those log file you're going to identify only for errors or warnings. Correct? We will be getting debugs and info and a lot of things we will get in the log file. You just going
Yes,
to
yes,
filter only for errors and warnings. Which
yes,
lines will comes with errors and warnings, that only you're going to refer it. So what will be
yes,
happen? Your log files have 1 GB of data, it's unstructured. So wherever the logs will comes with errors and warning in that keyword, that data only you just sliced, correct? And then your log is a new format of, from old format to new format, you have another one log file. You're not doing any computations, just transformed from one format to another format, correct? Is it right?
yes,
Right?
yes, yes, yes,
So
yes.
that is called transformations. In this transformation, we have narrow and wide transformation. Narrow transformation is nothing but directly with
That is
respect to
one
your,
form to another form, right?
yeah,
Structured to unstructured data.
whatever structure or unstructured, one form to another form is the correct word.
Whatever data it may be, structured data or unstructured
Yeah,
data.
whatever the data, that with respect of your selection, it will be transformed from one form to another form. Okay.
Okay, okay.
One
So
form to another form in the sense what is that one form to another form?
I'll come to you. Mm, okay, we have a Olympic data sample. I just take it out right now. Okay, in this data, I have few records. Okay, something is a column. So this is actual data. I'm going to filter only swimming data right now. Okay, so same structure, same form of data, you just filter. This is one form to another form, you just take it out right now. Out of 1,000 record, you just filter some record only for 500, close to 500, 487 records. You just transformed your data. And then you just going to slice again with your data overall comes from India. India. Okay, for example, overall comes from Canada. So only 5 records. So this is also another one format. Actual record you just transform to another format, right? And then you just only take for names, or only you will be take for this much of information only. These are also transformation, right? Is it correct?
Yes, yes,
Yeah,
yes,
yeah.
correct.
Yeah, these are all will come to
Dinesh,
transformations.
Yellen here, and this is not like another form. We are just filtering, right? How do you say
We
this?
are
How do you say this is transforming from one form to
Yeah,
another? You're just taking
yeah,
Excel and you're filtering. That's it.
that's a filter is a form, right? You have an entire the data set, you just transform to different format. Let's say, for example,
no
the same
form.
data you'll be doing with multiple joints. How it will be? You'll be have this data you'll be doing with another one joints, right? You have two tables. One is volumic data set, and one is with respect to of ID number or something. You just join two tables. At the time, it's a transformation has happened, right? Are you doing any computation there?
Yeah, transformation only, but it's not another type, right? It's a CSV. It is a table for structured format, but a different.
I'm saying about the transformations only right now. These are always
Oh,
called a transformation. So first, if you are trying with the joints, what will be happen? You have 4 columns plus additionally you'll get from another one tables with 5 columns. Just combine it. Just join both and create it as a new table format. Correct? So that is a transformation. Are you confused still? Data frame, how many of you are using right now? Okay, this is a new batch only for Spark, right? Okay, Hive, you have a 2 tables, right? Hello?
yeah,
I hope everyone is working with Hive, I guess, right?
yeah,
How many of you tried with the joints in Hive?
yeah. I tried.
How many mappers were run in the backend? Mappers and reducers.
For mappers, mapper will run, only one mapper will run. Reducer will not run
What is the reason behind?
because it is not. How to say? Join is doing a column based. Only it is doing the matching records, right? So that's the reason reducer will not work.
No, no. Join the reducer will perform.
No, join. I checked it. Join for genuine reducer will not run.
Yeah, map side join and that one only the reducer will not perform.
No, no. I am
Remaining all
saying
joins the
normal join. A normal join, it will not. Reducer will not work. Only mapper will work.
no, no, no.
If you put count or something else or group by or
Yeah,
order by, reducer will work.
Yeah, for any
Because
join
it's
also
doing, because it
it
is
reshuffling.
works.
doing, reducer will doing the sorting, shuffling, everything. But in join,
Yeah,
there is
join
no
also
sorting.
shuffling will happen.
I
Okay,
don't think
okay,
so.
guys, wait. This is your assignment. You just try tomorrow and tell me how many mappers and reducer running in the back. Okay? And
Yeah,
a
okay.
simple
Yeah,
join on class, you just connect and find out how many mappers and join reducers running. And then another one scenario, you just check with count or something else. You just check and get back to me. Okay?
Okay,
That's a
sure.
tomorrow assignment. Tomorrow morning, I will ask you before the session. Okay?
Okay, okay.
Hive, right?
Yeah, Hive, you just take two tables and do some joins and final output. At the time, how many mappers and reducers is running? That I need to identify from you. Okay? And
Okay.
two joins you need to do. Select star from table A, join with table B on class something, whatever. This is the one query. Another one is select count or something from table A, join with table B, where class or something you just mentioned. So you just execute these two query and get the data with number of mapper and reducer information. Okay. So, okay, I'll come back to this. This is a transformation action. So in transformation, directly from one format to another format, Okay, it's still now the people are confused from one format to another format. Let's say, for example, I just using some regular expression format. Okay, we will take for log itself. So log have info, error, warning, debug. So one critical or something. This 5 information we will get. So I just collect the data, ABC something. It will be available. Info also is available like this. Okay. So some data will be stored like this only. So now I'm going to filter my data and collect it. Only for warnings and errors I'm going to collect. Okay, this is unstructured data only. And then I just split via space and get the data with warning. And this one is like a name I will be taking out. As a host who will be login, that IP address we will be getting from here. These two information only I just slice and getting the data. And finally it will be structurized and we'll get that output as error, ABC, warning, JJST something. So I just declare this as a structurized format and mentioning the column name as column 1 and column 2. Okay, so this is the way I just split the data and create it. Are you agree? This is a format of structure from unstructured to this unstructured to structure format. One form to another form. Will you be agree this?
Yes, Dinesh.
So
Yes, yes.
this is possible from your Spark transformations. You just declare and get the data. That's it. As a any one format, as a different RDD format or different data frame format, you'll be getting. If suppose this all the information available in same node itself, in same node itself, you
Hey,
will
Divya,
not.
connect me.
Yeah, tell me. Any question?
No, 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 Dinesh.
Okay, so let's say for example, this all the data, let's say for example, errors, info, warning, all data node have the information. Here also errors, that 6 block of data is available in data node 1 itself. You'll be filter your data, info, error, warning. It here itself, it's called narrow transformations. Okay. Okay, I just mentioned without shuffling. That's a simple word. Okay. Another one is you'll be doing some joins and group by. At the time, what will be happen? This data will be transformed to here, and this data will be transformed here, and this data will be transformed here. Something data will be shuffled right internally. That everything will be called as wide transformations. Whenever you will be doing the joins or group by operation, at the time your data will be shuffled internally with your Hadoop environment. Because then only all the data will be with respect of key and values, it will be transformed. Is it right? So that is called as wide transformations. Okay. So whenever the wide transformations happen, at that time, stages will be created. Stages is nothing but it will be with your operations with the DAG and producing a final output to you. So let's say, for example, I am filtering the data. Okay, I have 1 GB of data, 1 GB of employee data. This data I am going to filter salary more than 50,000. Overall, getting those data only I'm going to collect it. And then I'm going to group the data.
Yes, sound okay.
Hmm? Tell me, sir. Okay, joining with the department. So which department with respect of this guy is available? This information I'm going to collect it. And finally, I'm going to group the data with respect of department names. Okay, this is the flow I'm going to do it now in Spark. Okay, here data is actual. You will be collected and filter the data. Just filtering the data, it's called narrow transformation will happen. Once you filter the data, those data you're going to connect with your department table. At the time, your data will be shuffled because few records is available here, few records available here. It will be shuffled internally with the department and employee table. Both will be shuffled. Here, wide transformation will be created. And then you will be going to grouping your data. Just grouping the data with respect to your department name. There you will be going to execute some actions. Correct? So what will be happen? This action means this will producing your outputs. Whatever the computation will happen, that is called as actions. You got my point? So finally, that action only will be executed. Okay. So till now, you just transform the data and finally you get some output, right? Whether it is a count or sum or whatever, that all will come to actions. Very clear? Just a minute. I have personal office in like 1 minute. I just just a minute, guys. Okay. Are you able to see my screen again?
Yeah.
Okay. So that is called as action. Whatever the data, finally you're going to get some computation output, right? That is called as actions. Meanwhile, whatever you're doing, all that will call as transformations. Okay. So simple comparison with map reduce. Wherever you are doing the mapper operation, that will be compared as a transformations. Wherever you're going to do some reduce operation, that will be compared with actions. Got it?
Yes.
Any question here?
Wherever the map is called as,
Transformations. It's a comparison based, I'm saying.
okay, that is transformation. Reduces is nothing but the actions.
Yeah, reducer is point of actions. Okay, example is I'm saying with filter your data. Okay, joining your data. These are all for examples of your transformations. Just transforming your data. Action is counting your data. Some count some
Average.
average. So whatever. These all come to actions. So what is union? Union is action or transformation?
So action.
Is it action? How many of you saying as actions?
It's a transformation.
Ashar, how many of you saying as transformation?
Union, we call it as both actually, transformation plus action.
Guys, you just check from your end and will update me tomorrow. This is also your assignment. Union is the transformation action. You just check in Google or check somewhere and get back to me. Okay, then only I can understand how much you will be understand about this program. So small assignments I'm providing you. Okay, then next we will go with now lazy evaluation. To know why we are discussing the transformation action with respect to of transformation action, lazy evaluation will be performed. Okay, so whenever the action will comes, until that Spark will not do any transformation operation because you are going to develop the code, right? So at the time when you are going to mention with action, at the time only that entire flow will be running. Here you can see narrow transformation and then wide transformation will be executed and finally only will be getting with actions, right? So whenever the action paused at the time only your entire flow will be running back in. What is the reason behind we have to go like this? Why we need to do like this?
So as it follow DAG concept here,
Yeah, where the data is available, that information you will get from DAG. But why lazy evaluation we have to follow here? What is the reason behind?
so it will only execute the necessary steps like and helps in speeding up the process. Many unwanted steps will be removed, will not be executed.
Partially correct, but actual answer is not that. Lazy evaluation. What is the main use of lazy evaluation? My question is, why Spark mainly follow with lazy evaluation?
Memory consumption and time consumption.
Can you explain more?
Yeah, once we trigger the job only, we can while submitting the job, we have to mention what kind of job name and which memory, how many memory executes. Otherwise, it will take the header memory and worker node memory.
Yeah, correct. It will lock the memory because entirely we will be running only with memory in memory only, right?
Yeah.
So what will happen here? 10 GB space available. Here 10 GB. Each have 10 GB of space RAM is available. my job will be running with 40 GB of data or 30 GB of data. So until you will be releasing the memory, it just occupied for the same job. So it's completely wrong, right? Your architecture completely wrong.
Yeah.
So that's the reason they will be using lazy evaluation concept. So if you have an action at the time, at the simple single flow, it just execute all the transformation and action. So it's this is for, let's say for example, this flow will be take for uh, 30 GB of data. Okay, 1 GB I mentioned. Okay, 30 GB of data. This 30 GB of data at the same time it just move into the memory out of 40 GB of RAM total. 30 GB of data and filtration will be complete itself, and then it's execute with joins with another department table, and finally it's collect that final output and send back to you. Okay, so it takes only 10 minutes of time, your entire data. It will be perform your entire the operation and release your memory itself. Correct?
Yeah.
It will not be occupied any memory in that, so other job will not be get affected. Correct?
Yeah.
So another one job will come with a 50 GB of data or 20 GB of data. Within a 10 minutes, we can complete our work and release the memory. If suppose I didn't execute my,
Actually, how much memory can available in memory?
that's with respect to of your cluster size. Data
Okay.
node, how much data node is available with respect to of those sizes, you know. Okay,
Yeah.
because your Hadoop architecture or that size, you know very well. You are
Yeah.
going to design, right?
Yes.
So that's the reason the other job will not be delayed. This is the main prior reason they will be using lazy evaluation. Got it?
Yeah.
Any question? So this is a Spark one
So
job.
see, yeah, lazy evaluation is nothing but just comparing it in short form.
Spark job one.
Yes. Dinesh, lazy evaluation is nothing but where you have to keep the memory space.
It's releasing the memory space. It will not be immediately allocate the memory. That is the use of lazy evaluation.
Okay. So if some other process is asking, it will release the memory space for their jobs.
Yeah, let's say for example, two jobs I'm running. One is 30 GB of RAM, another one is 20 GB of RAM. Your node, your cluster size is only for 40 GB of RAM memory. Okay.
Okay.
So at the time I'm executing one, another one is third job.
Okay.
So 10 GB of employee table, patient HR, okay, something HR data set. So total you have only 40 GB of RAM memory totally. So 30 GB if it is allocated without completing the action, it will not be released. So another two job will be in queue. We cannot complete it, right?
Yes.
So if we will be using with the actions itself as a lazy evaluation method, this job will be running in your memory and complete your task with 10 minutes. So this job only wait for 10 minutes of time. And then just this job is going to be start in your memory and complete this job in just 5 minutes of time. This job only completed in 2 minutes. So this 2 minutes until that only your memory will be locked by a Spark. Okay, and then it
Okay.
just released. So
Okay.
continuously
So,
whenever the job is going to be submit, it will not be failed. Continuously it will be producing the output to you.
okay. So it's in the
And it's
pipeline.
yeah,
It's in the pipeline, 20 GB and 10
exactly. Lazy evaluation follow with your transformation action pipelines only.
So once the job 1 complete, then job 2 start.
Exactly. Not
And
like that.
job 3.
If you have a memory space, it will be continued. Total 40 GB I'm saying, right? So 30 GB and 10 GB space is available. So two jobs parallelly will be run in your cluster. If suppose I have the sizes of clusters, sorry, if I
Okay.
have the space, let's say for example 40 GB of total sizes, I'm running two jobs, this two job. So this is will not be occupied entirely with your RAM sizes. So what will be happen? It just accepted stage and waiting in the queue. So 10 minutes, this job will be taken and this will be completed. Once this complete and release the memory, this job is going to be occupied with 20 GB of RAM memory and perform it. So frequently you can do your analysis with the Spark cluster very efficient manner. It completely lock your memory. For the time being, just lock your memory and complete your work and come out. If suppose you will not be lock your memory and you will not be using any actions, so you will be develop the code for the action and you cannot complete. So till that this in operation will be locked your memory, other jobs will be getting failure, right? It's a complete bottleneck to you. That is the reason they will be developed for lazy evaluation concept. You got my point?
Yeah, got it, got it. So it's a
That,
bottleneck for the other jobs to run.
exactly.
Dinesh,
Yeah.
if you mention some memory in that Spark submit, while Spark submitting, we have to mention some
Yeah.
memory, right? That is a
Yeah.
in memory or a cluster memory.
That is a in memory how much you need to allocate for the particular driver, particular executor, that you will be calculated and provide to them. You know
Yeah,
about very well about your data, then you can provide how much memory you need to allocate for my project, my job, like that you can provide it.
yeah, that is
User
in
combined.
memory only, right?
Yeah, in memory only. That's
Yeah,
executor
yeah,
memory and driver memory you have mentioned only for in memory.
yeah. Okay.
Okay, any question
Nothing,
guys?
nothing.
Are you clear?
Yeah.
Yes, yes.
Yes, yes.
So till now we are discussing about the Spark basics. Now lazy evaluations, early transformation action stages. Okay, so stages, actions, transformations, DAG we have discussed, lazy evaluation we have discussed. Anything did I missed? DAG, okay. So master node, driver node we have discussed. And architecture, I forgot to tell you executors. So driver memory, sorry, driver node and worker node, each will be created internally with one is called executors. So this executor only your memory will be allocated, your number of core will be allocated, everything will be allocated here only. Okay, these are only interview questions they will be asking you. Cores and RAM. So each job it will be allocating cores and RAM and will be performing with you. Okay, driver node, worker node, executors, we have discussed how the flow is working, yarn architecture. Guys, till now, any question? Any doubts here?
No, Dinesh.
Okay. I think I missed. And cluster management, yarn is available, cluster management, and Meso is also possible. Yarn is a kind of cluster manager, especially for Hadoop, and Mesos as a cluster management will be possible and standalone. So 3 will be running. Okay, that's it, I guess. The basics. Now we just going to discuss about RDD. RDD means resilient distributed data set. So what is RDD? This is the first interview question. Mostly the people will be asking to you. Anyone can answer?
It is a parallel computation for Spark.
Okay, correct. Close to correct.
And it will do some partition of data in Spark.
Come again.
It will do some partition of data while we giving submit job. It will immediately it will partition the data and load it to the clusters.
Okay, why we RDD is an important?
It is the basic data type actually.
Sorry, your voice is breaking.
It is the basic data type actually in Spark.
It's not a data type, sir.
Not a data type, but like data frame is built on top of RDD. So it is the basic unit of
No,
Yeah, close to correct. It is a parent. That's what I just mentioned. Parent competition for Spark. That's I mentioned. So data partitioning. So RDD helps to reconstruct your data.
they will execute row wise. That's why.
Just a minute. Because little noisy, I just mute you, all of you. If anyone doubts, you just unmute and ask me. Okay. So it
What is
reconstruct the data.
RDD?
Resilient distributed dataset is the full meaning. So what is that means? The actual meaning is it helps to reconstruct your data. In case of any fault tolerance. Okay, that is the use of RDD. So let's say, for example, you just run your code, right? You just submit your job, it's running. So data node 3 is going to be failure. Immediately you need to start your operation data node 1 and 2, right? So this will be reconstruct your data here only. So 6 block I just allocated, 6 block is going to be fetched the data from data node 1 and data node 2 and immediately it will start the process without failure. Correct? This will be controlled by RDD only. It helps to reconstruct your data whenever it's going to be failure. So what will be happen if you will not be looking without fault tolerance? You will not be considering the fault tolerance in your data set in your Spark cluster. What will be happen?
The data will not come.
The output goes wrong, right? So let's say for 2 GB of data you will be started and 2 GB of data 16 block will be splitted. You can calculate it only for 14 blocks of data. 2 blocks is going to be failure. You cannot create it at runtime. Where the replica is available, there you can need to get those data and create it again and run it, right? That is the way you have to achieve it. But that will not be happen. So your data final output completely collapsed and it's waste of your time, right? Is it correct?
Yes.
Yeah,
So
come
that
again
are
in.
all. So that are all will be controlled by RDD only.
Okay, so
Okay.
so if something is, we have to arrange it, then the data has to be in place. That then RDT will take space. So
Yes, exactly.
like you
Yeah.
said in the
Yeah. Go ahead.
like you said in that cluster, no, job 2, job 1, 40 GB,
Hmm.
40 GB. That uh, the cluster
This.
mode, it was 40
Yeah.
GB is just
Yeah.
job 1,
Correct.
job 2, job.
It
That
just
is
partitioned your data. And suppose if you are not getting your data exactly, what will be happen? Your job completely going to be failure, right? So whatever the data it producing to you, that output also is wrong. If you are not be considering the fault tolerance, so we have to mostly uh, we have to mostly verify with the fault tolerance is important. So that's we will be checking here and then we will be started. So here my job will be running with 10 tasks. 8 tasks is running successfully, 2 tasks is failure. Immediately that Spark is going to be identified which 2 tasks is failure continuously. And it's going to be identified the replica where the actual data is available. So it will be recreate a new 2 tasks and execute it again. So total 10 tasks once it is completely finished, then only that output will be getting to you. Okay. So that is the follow-ups will be taken by RDD operations. In the programming base, RDD is a kind of abstract they will be using. Okay. But actual meaning reconstructing the data in case of any failures. Got it? Any question?
nothing, Dinesh.
And RDD always immutable. Why immutable? What is immutable?
We cannot change the data. While assigning to one variable, we cannot change the data.
What if happen if the data will be changed at runtime?
If data
Fault
is
tolerance
changing,
will be difficult to maintain if data is mutable here.
Not exactly. We can maintain our data, right? That will be available in Spark cluster, sorry, Hadoop environment itself. But why we need to select as it immutable? That is also part of fault tolerance, right? In case if you are going to delete some data at the runtime, you will be changing your data set format. What will be happen? Your final output getting back to you. I have 1 GB of data. Okay, let's say for example, in this example, I have 30 GB of data. I'm going to execute it at runtime. I just lock the memory with 30 GB of data and execute it. Immediately, I just change the data into 20 GB or 40 GB. What will be happen? Data going to be clumsy, and all other operations is going to be wrong. Right? You filter the data. Again, what will be happen? It's going to be make some joins here. Data will be collapsed, so you cannot retrieve the data. So proper information will not be getting into the final output to you. So whatever the data, that job succeeded is very important with efficiency manner and clear output visible. If data will be modified or changed, your entire the flow is going to be wrong at runtime. That is the reason RDD always will be created as an immutable data set. Okay, clear?
RDD will keep the backup of the data, or
It just partition your data, right? And then it just move into the memory. During that time, if any changes was happen, it will not be considered on data. Once the partition data will be moved to the memory. Okay. Let's say for example, you have a 10 GB of data in your drive. Okay. So this 10 GB of data is just move into the memory. Immediately you just replace the same file name with 2 GB of data or something. So it will not be considered until this job completions because it's already moved into the memory. Okay.
okay.
That is the reason of immutable. Once the job is completed and resubmit again, at the time if it is a 2 GB of data, that time it will be considered. Whenever the action paused, at the time only all the flow will be running at the runtime. Got it?
Okay, got it.
So RDD we can create in 3 types.
3 types.
Yeah.
Three types. What are they?
Does anyone know? If you knows that, tell me.
Using existing RDD.
Okay, that is one.
Using some files, JSON or CSV or text file.
That is called as external sources.
External sources.
And then from collections. Is parallelized. They are calling us parallelized. So this 3 way we can create RDD.
This?
Sorry, I'm not getting crazy.
No, the 3 ways. One is external source.
And another one is collections. Programming collection.
Programming
listed tuple, something is available, right? It's a grouped data. So with respect to of grouped data, you can create your RDD.
Okay. The first one is
Old RDD to new RDD format. Let's say, for example, I just mentioned, right, the transformation. So you have a data, you just filter the data, right?
yes.
This data will be created as a new RDD format. Okay.
Okay.
So tomorrow we will go with entire hands-on RDD itself. No issues. Okay.
Okay. So
Any questions?
RDD is part of Spark.
Yeah, RDD is a base, is a parent to computations. After that, only Spark will go with the data frames or something more, data set something. So whatever it will be available, that will be a RDD only. Okay, and
Okay.
RDD will be created based on the context. So what are the contexts is available? Tomorrow discussion we will be discuss about that as well. So we have multiple contexts available, Spark context and high scale context something. So
But
that we will be
Dinesh,
discussing.
everything is come under the Spark session right now.
Yeah, that is just two expression. That I will tell you in tomorrow. Okay, so context we will be discuss everything. How many of
Okay.
you noticed a Spark 3 expression?
Spark 3 came, Dinesh.
Spark 3 is going to be run. The preview is released and actual they are going to release soon. Spark 3x. We have moved to 3 expressions. So. Okay, later that we will be discuss. Okay, is it fine?
Okay.
Okay. It's
Any
okay.
question?
Yeah.
Any question?
Like Spark 1, Spark 2, Spark 3.
Yeah, Spark 3, they have released the basics preview, still not come to that constant. So, but that's a stable version for future, I guess so. They're make a lot of input in that.
Okay. Oh, okay.
And I just want to know all of you is go like to go with only Scala or Python tomorrow session answer.
What is R?
Or programming we can, but we will be take the sessions only for Scala or Python.
For me, Scala
Python
is
is good,
fine,
no?
Dinesh.
Python
Which
is
one?
good, no?
No, with respect to of your team, I would like to go with the no issues, but need to confirm which one I have to go right now.
Python, Python.
How many of you? Because mostly Dinesh
Py-
Pandey will be covered in Scala, but I would like to go in Python. So if he will be taking the session, you may be in Clumsy, so that I just confirm you before itself.
Like for data
No,
engineering
because
work, Scala should be more preferred, right? So that is why I go for Scala.
no, Python is a high demand, right?
That's true, but for data engineering work and even for data processing speed, Scala will be faster actually. But when you want to link your machine learning things with the data
Let's go
processing
with
work,
voting. How many of you Python? Just mention in chat. 3 people mentioned Scala, so we'll go with voting right now. Who are interested Python or you just mentioned? Precious. 1 Python, 3 Scala. You just mentioned in the chat everyone.
Python, Python.
4 Scala, 2 Python,
Python.
3 Python, 2 Python, 3 4
No,
Scala.
no, where I have to vote?
You just mentioned in the chat. Chat to everyone. Precious.
I don't see any chat.
In Zoom we have a chat, sir.
1 second.
We'll go with voting no issues. Because with respect of people interest, we would like to go with that.
Just include my name.
You
Python.
just type everyone, automatically will come. 4 Scala, 2 Python.
1 second. I will type it.
Everyone, all of 15 members right now. 3, 4. 3 Python, 4 Scala. And I just want to know the people know about Scala program basics because it just stuck up.
I know a little bit, Dinesh.
If understanding is fine, so that I just asking for everyone who is typing here. 4, 3. Others? I think they are in dilemma. Anyone I'm comforting, I guess. Aravind, you are a double entry. It will not be considered. Okay, so Scala only that most of them asking, and also who's Dinesh Pandit also would like to go with Scala. So tomorrow session I can go with Scala itself. And please prepare the basics of Scala today itself. Then only you can understand what is happening in the backend.
Sure.
Okay. You just go through about the Scala basics, and then only Spark you can understand. But I'm saying, if you, how many of you saying as a Scala, definitely you must learn about Java dependency in future. Not now, in future, because the job mostly in Scala they will be looking with Java. That's a native library. So in future you have to learn about Java as well very well.
Okay. What about Python?
Python is a separate, right? It's not required to learn about Java. There is no dependency. You need to learn about the multiple packages, how you'll be interact with the Spark environment. That you need to learn in Python.
So Python is somehow related to C Sharp or
Not required, sir.
C++.
Python, we can go with Python, Jython, something is available. But in the Spark environment, how you are efficiently you're going to interact it with your packages. That's you need to learn. That's it. Because n number of packages is available in Python. So that's you need to learn from Python packages. That's important. Okay.
Okay. Okay.
Okay. If any questions, please rise now. Otherwise, we can wind up the session now. I guess no.
Yes. Yes. No.
Okay. Thank you all for joining today, and we'll be connected by tomorrow.
Okay. Dinesh,
Yeah.
I just want some basic questions.
Yeah. Tell me, sir.
No, this is separate. I want to know about the initial things. That Hive and all you said, right? Hive. That component difference only I want. Hive and see, just for Hive is similar to Spark or what is Hive and just some basic thing.
Hive is not taken. It was taken by the session people, right? I guess. So Hive is a data warehouse ecosystem. How efficiently you're going to handle your data with the Hadoop environment, because Hadoop completely follow with file objects, right? So only you'll be stored everything as a files, correct?
Yes.
So those files, while you're slicing your files data, you have to mention some data type and column name, correct?
Yes.
So those information repeatedly you don't want to giving to them. So that information will be stored in somewhere. Whenever the query will be shoot at as a SQL query in Hive, it's going to be refer your file object with respect of your data types and column name and executed. So latency will be avoided. The data will be sliced very efficiency manner. That is the use of Hive. Okay. So let's say, for example, CSV file have name, salary, ID, name, salary, 3 column. So whenever the Spark job, sorry, not for the Spark job, MapReduce job, whenever you're going to execute, you need to slice the data based on the comma separator, and then you need to mention some column name. Whenever you need to execute the query, it just going to be slice your data, and then only it's just mentioning the data type version, and then it's started. So this many times we can avoid it via Hive, because already you pre-define and it will be stored in some metastore information. Whenever you will be shoot your query as a SQL query, it just entirely convert into the MapReduce program and working on top of your Hadoop directory. So efficiency very high manner and getting the data very faster. And some optimization techniques available, partitioning, bucketing, maps and joins, lot of things are available that we can implement and do some analysis on that. So Hive mainly used for data warehouse slicing operations. And it will be very support for SQL developers who doesn't know about Java or programming. Only they know data engineering as a SQL. They can simply work with Hive and very easy. Okay. So in the Hive
Only
session separately will come. So other time I'll tell you. Yeah, tell me, sir.
Okay.
Okay. Any other question? If no question, we can wind up the session today.
Okay. No question, sir.
Okay. Thanks to all. We'll be connect by tomorrow itself.
Okay, the same time, 9:15.
Yeah, exactly.
Okay.
Yes, by 9:15 to 11:45, no session.
Okay. Khalil, anything else you wanted to say? Or we can wind up.
That's it, Dinesh. Like,
Okay.
we can wind off. Yeah.
Okay.
Thank you all.
Okay, I'll disconnect. Thank you.